So as we discussed in the introductory video, differential calculus allows us to find an equation for the rate of change or the slope of a particular equation of a graph, right? So the first principle is a method of differential calculus that actually allows us to find the derivative of a function. And it is worth noting that although this is quite a well-known method, it's not always the most favoured, but it does come useful in quite a few scenarios, so it's worth understanding. So to differentiate a function using first principle, we use a theory of limits. And you can look further into some of the background behind how the function's created, but the derivative function using the first principle will give, so we've got f of x as a function, then using the first principle will be given in the form, so f of x equals lim, so for limit, lim and h approaches 0, and different values can be used for this, but this is general. And then we've got f of x plus h, and I'll need to make that longer, minus f of x, and then we divide this all by h. Okay, so to get an idea of how we can actually use this method, let's look at a general scenario. And so we've got f of x equals 3x, and this is just so we can start off with a really simple scenario. And so what we're just going to do, like we will need to do every time, is just write the formula out, and I'll just write this out really quickly for us. This way we can actually then input all the values into this general function. And so I can then just say equals, and every single time we evaluate it, we're going to need to, again, as annoying as it may be, write lim h approaches 0. And so we've got two main parts we can look at. We've got this and this here. And so this part is really simple. We just input that because we know f of x is that. But in the other part, we obviously have h in it as well. And don't worry, this doesn't make it too much complicated. But what we would do with this, for this, is we would just write that as, so f, so 3, and then every time we have x, we'd write x plus h, so it'd just be 3x, or x plus h, as simple as that. So let's just put that into the thing. We'll just write that out as 3x plus h minus 3x over h, and we don't need to do anything with the h's yet. And what we do here is we're going to evaluate all of the parts that we have. So we have 3x plus 3h minus 3x. And what you'll notice in hopefully all of the functions that you look at, we have to find the derivative using first principle, is that any values in the equation that don't include h should cancel out. So we can see that 3x, we've got minus 3x as well. And so pretty simply, we can just look at this and go, oh, cool. We can cancel these two values. And that makes it really simple for us. So we just write this equals lim, h approaches 0, and don't mind my crappy writing. And then that's just 3h over h. And then you can start to see this get a lot simpler from here. So we can then, again, cancel what's common. So we've got h common there. So we'll get, which equals lim, h approaches 0, and what we've got here is 3. And it's worth stating that we need to say here, since h doesn't equal 0, because looking at the background of it, we can actually see that h approaches 0. So h doesn't equal 0 exactly, but it approaches it. Because if h was to equal 0, then we wouldn't be quite getting the same values. And then we can just evaluate this. Let's try and squeeze this in here as just equaling 3, as simple as that. And so then we can see, if we look at it from the beginning, that's so f of x equals 3x. Therefore, f dash x equals 3. Okay, cool. So we know the general form. So now we just need to look at a few more bit more complicated scenario. So this time we're going to look at f of x equals 2x to the power of 3. So we've obviously got a few more variables here now. So I'll just put in the general equation. Cool, and now let's just put in the values that we have. So we know that now where we've got x plus h, all we need to do is we need to just put that into where x is, really simply. So we'll just do that. So we'll just have 2, so 2 at the front, x plus h, and now because we've got the power of 3 there, we can do that power of 3 minus 2x to the power of 3, and then over h. And then what we're going to need to do is we're actually going to need to use binomial expansion to actually evaluate this there. So I'll just do that really quickly. So we got this equals lim h approaches 0, and then what I'll do is I will condense it, but basically what I need to do for it is I'll have x plus h times by x plus h and x plus h, again like that, and then you can multiply those two, and then multiply this by that. It doesn't really matter about the order, but then if we were to do that, this will give us, and I'm just going to keep the 2 at the front for now, 2, we'll have x to the power of 3. Or alternatively, we could just use Pascal's triangle. And so if we were to look at the coefficients, we know that we've got to the power of 3, so it'll be that one there. So what we'll get is we'll have x to the power of 3, so coefficient 1, plus 3, because we've got the 3 there, 3x squared h, plus, so hopefully this all fits in, plus 3 again, x h squared, then plus h to the power of 3 with coefficient 1 like that, and we can close it off, minus 2x to the power of 3, and then this is all over h. And then we can start to evaluate this more, adding the 2 that we have there. So I'll just write this, so lim h approaches 0, evaluate all this, we'll have 2x to the power of 3 plus 6x squared h plus 6x h squared plus 2h to the power of 3 minus 2x to the power of 3, and over h obviously. But like we described in the example before, is well, these all have h in it, which is awesome. And, oh, whoops, I removed a little bit. But what you can see is the two values without h's will both cancel each other out. So we can just cross them out, and that will give us, obviously, lim h approaches 0. And beyond just cancelling the 2x to the power of 3, I'm also going to take h common, so then I'll have 6x squared plus 6xh plus 2h to the power of 2 over h. And I think you can see what I'm about to do here. So I can then cancel these h's here, and then this will give us lim h approaches 0, and then we will have just 6x squared plus 6xh plus 2h squared. And what I can say is, well, here, since h doesn't equal 0, that's why I can cancel this out, because we know if we were dividing it by 0, then we would have an undefined value, which we cannot have. And then what I'm going to do, so I'm just going to do this here because it should fit better, is I can just say this will equal 6x squared. Whoa, what just happened there? So we can see that both these have h's, and we know that h is approaching 0. It's not 0 exactly, but it's approaching it. And so what I can actually state here is that as h is approaching 0, we can say that 6xxh plus 2h squared also approach 0. So fit that in there nicely. So what we're saying is these two values here both approach 0. So they're not 0 exactly, but they approach 0. And so then we can say that the derivative for f of x is just 6x squared. Okay, so now that we've done that, I reckon we're ready for something a little bit more difficult. So we've got f of x, and I'm going to have to do this one smaller because it's a bit longer. F of x equals 1 over 2x plus 3. So we actually have a fraction here. So I'll just write in the general equation first, and I'll do it up here so we can make sure we can fit everything in. Okay, so we know that we put x plus h wherever we've got an x, and that still applies in this scenario despite the fact that we actually have a fraction. So we can then just write this as equals lim h approaches 0, and you'll see how this can get a little long decently quickly. Is we'll put this in like this, and we're just going to write this value 1 over 2, and we're going to have x plus h here, and then plus 3 follows that equation, and then just minus the general f of x equation, which is just 1 over 2x plus 3. So we can then do the next step, and this will just involve a bit of cross multiplication actually. So what we're going to do is we are going to multiply this with this and that with that. So let's just do that real quickly. Big bracket here, we're going to have 2x plus 3, and this is just going to be a really big bracket like that, and then it's going to be minus 2, we'll do this here, 2x, and this is just evaluating or expanding that, I should say. So 2x plus 2h plus 3, like that, and then that's over, we've just got to multiply that with that for the denominator, so it'll be over 2x plus 2h plus 3, and then 2x plus 3 like that. Close that bracket, and that is over h, and then that will equal, we can go lim h approaches 0. And what we can notice is, before even evaluating some of this, these two values will cancel, and these two, which aligns with the ones that don't have h in that, and then so we can just evaluate them as we have negative 2h over, we'll write this big equation again, 2x plus 2h plus 3, and then 2x plus 3. This looks very rough, and then that will just be over h again, and then we can then say that this equals lim h approaches 0. And what we can do is we've obviously got, we can look at it like this, we've got this fraction over h, and so because this bit's on the numerator, we can actually cancel this h and this h, and then that will just give us negative 2 over the big equation again, so 2x plus 2h plus 3, and also 2x plus 3, and I should also state up here that as h doesn't equal 0, and then what we can do is we can actually cancel that because we're getting rid of all the things with h in it, and we can state that that says as h approaches 0 to h approaches 0. And what we can notice is that in this bracket, now that we've cancelled the h, we've got 2x plus 3, and we've got 2x plus 3 there, and so we can literally now just give our final answer as negative 2 over 2x plus 3 squared, and then that's our final answer. So let's just look at one final example that's a little bit more difficult, that actually considers roots now. So we've got f of x equals 2 root x. So we'll just write the general formula. So what we're going to do is we're just going to do what we've done before. And we're just going to write an equation. So we've got where we just put x plus h, where x is minus the fx normal formula. So we'll just have 2 square root x plus h, and then minus 2 root x, and this will just be over h. And then what I'm going to do, this is where it will get a little bit tricky, and I'm just going to do this in blue, I reckon, and I would do it over here, but we're going to use that space in a little bit, is I'm going to times this equation by the numerator, but instead of minus, it will be plus the function, so it'll be that plus 2 root x, because we're trying to get rid of these roots on the numerator, and then this will just be over the same thing, x plus h plus 2 root x, like that. And then we can just write our equation again, so this will give us lim h approaches 0, and then we'll have the equation 4x plus h, because we know multiplying this with this, these two will just 2 times 2, and then 2 roots give a whole number like that, and then that will be minus 4x, same theory there, and then we'll, because we just got h on the bottom, just have 2h root, so now we do have roots on the bottom, but that's alright, that plus 2h root x, simple. And then what I'll do first is I'm just going to evaluate it in a way that's a bit more presentable, and we can do a little bit more with. So we've got lim h approaches 0, we'll just evaluate this top one, so we'll have 4x plus 4h minus 4x, and then we'll have 2h, and I've just taken this common, then root x plus h, then plus root x, like that, and close off the bracket. And then we can start to cancel a few things, so we can cancel these two to make it simple for us, which will equal lim h approaches 0, and then 4h, and then just write the same denominator again, x plus h plus root x, like that. And then what we can do is we can do a bit more cancelling, so we got the h's there, we can cancel the 2 as well and make that a 2, like that. And I will actually just section this off so we can do it on the other side, so that will equal lim h approaches 0, and we're going to have 2 over root x plus h plus root x, like that. This will be, and because we've cancelled those h's, we need to say, because since h doesn't equal 0, like that. And then we can just then give our answer, is because what we're going to do is we know this h is approaching 0 as we stated there, so we can cancel that, so we can evaluate this as 2 over 2 root x, because I've just combined those two values there, taking them common, and we can say in brackets as h approaches 0 plus h approaches x, easy. And then we can evaluate that further, and we can just cancel those two values, and we can get a final answer of 1 over root x. So therefore the derivative of fx is just 1 over root x. So now that we've found all these functions, what you can notice is that we've used a method to find f dash x, which is obviously the slope or the rate of change of the graph of f of x. And so any point along the x-axis, let's just say where maybe x equals 2, we can say, okay, what's the slope of the graph for f of x where x equals 2? And so now that we've actually found the derivative, we can just put that value into the derivative function, and this would obviously give us 1 over root 2. And then you can apply this kind of concept to a range of scenarios that require you to look into these values.